Electrical concepts. It's no news that electricity can be quite dangerous. But where is the greatest danger when working on an electric car? And what consequences can it have on your health? Let's start with the basics. We will explain the three most important basic electrical concepts again using the analogy of water flowing through a pipe. Ampere is the unit of current and indicates how much water flows through a water pipe. Volt is the unit of voltage, which represents how much force the water has as it flows through the pipe. Ohm indicates the resistance that the water, in our example, encounters. Instead of water through a pipe, in the case of electricity, electrons flow through a device, such as an electric car. In electricity, we have two types of voltage, direct current and alternating current, both of which can be found in electric vehicles. With direct current, DC, there is a constant voltage, and the current flows in one direction continuously. In alternating current, AC, the voltage of each pole alternates between positive and negative, causing the current to change direction regularly. When you touch a device with alternating current, in theory, you can release the device at its zero crossing point. However, the voltage changes direction at a very high frequency, typically 50 Hz. This means you have only 1/50th of a second to release the device. It's so brief that even with the reaction speed of a Formula 1 driver, you wouldn't be quick enough. The frequency of alternating current can affect your body. It can cause your muscles to involuntarily contract and relax, making it difficult for you to let go. The rhythm of your heart can be disrupted, leading to cardiac arrest. Your heart rate can fluctuate with alternating current, and then it can go into overdrive. Normally, a healthy heart beats about 70 times per minute, but when exposed to alternating current, it can increase to as much as 50 times per second. This makes alternating current much more dangerous than direct current. In a battery, direct current is stored, and the motor operates on alternating current. This needs to be converted. This happens in the inverters. The inverters contain large capacitors. Capacitors facilitate the conversion of direct current to alternating current smoothly. A capacitor consists of two sides that store opposite electrical charges, which can be used later. The capacitors can store the voltage for several hours. This can be life-threatening.